All right. So this graph here is the graph of the cost function from our last example. What we see in this function is something that's a little bit steeper at the start, then it flattens out a bit, and then it starts getting steeper again. Now, we really want to look at this in terms of marginal costs. All right. So here, what this is saying is at the beginning, when we have a low level of production, the marginal cost is kind of high to, say, move from producing 50 to 100 items, right? However, somewhere in the middle here, around the kind of like 1,000 to 1,500 production level, the marginal costs don't go up very much. The total cost doesn't go up very much, right? Because the marginal cost is a really small number. Now remember, the marginal cost is the derivative of the cost function, so we're looking at the slope of this function here. All right, so we can see for quite a while here, maybe until just before 1500, marginal costs are going down. And as long as marginal costs are going down, it's advantageous to keep producing more, because for sure that's going to bring down our average cost. Right? If it becomes cheaper to produce more things, then it's a good idea. All right. Well, then what we can ask though is at some point here, this marginal cost starts going up again. Should we keep producing if the marginal cost goes up? Does that make sense to do? Well, the answer isn't immediately obvious, but the answer is yes, but only if that marginal cost is less than your average cost. Right? Because the whole idea here is we want our average cost to be as low as possible. That's sort of the best place for us to be. So if we produce too little, the average cost is high. If we produce too much, the average cost gets high again. But there's kind of this sweet spot in the middle where we've sort of minimized our average cost. And that's what we want to look at how to do here. So what we're looking for here is, as long as the marginal cost is less than the average cost, to produce the next item will bring down our average cost. So what that means for us is we want to produce until the marginal and average costs are equal. Okay? So here, blue is the marginal cost. This is the derivative of the cost function. And here, orange is the average cost function. All right? And if we look at where they're crossing here, right here is where marginal costs take over average cost, where it becomes higher. And if the cost of producing the next item is higher than the average cost, then we see the average cost starts going back up. So this sweet spot right here, where the average cost is as small as possible, is really what we want to look for. All right? So that tells us that to minimize average cost, what we really want to do is set the two equal to us, or equal to each other. All right, so take the average cost and the marginal cost and set them equal. So let's see this with an example. All right, so here we have a small furniture manufacturer estimates that the cost in dollars of producing Q units of a particular chair is given by this function, C of Q equals 1,000 plus 5Q plus 0.01 squared. How many chairs should be produced in order to minimize this average cost? Well, let's look at an example of it, right? Or let's do the computation. So here's our cost. We want the average cost, which is this. We get 1,000 over Q. plus 5 plus 0.01 Q. Okay. We want to look at the marginal cost, C prime of Q. This will just be 5 plus 0.02 Q. And remember, from our graph, we're saying that the best spot, the spot that minimizes the average cost, is when these two things are equal. So we're going to say, take the average cost and set it equal to the marginal cost. Right, so we're looking at this. Equals this. All right, so let's solve this. So these will cancel. And we're left with 1,000 Q. And actually, let's move this to the other side. So we get 1,000 over Q equals, color rate equals 0.01 Q. All right, so I'm going to multiply this Q through, and we get 1,000 equals 0.01 Q squared. All right, and so Q squared is 100,000. Right. Now, Q, it doesn't make sense to have a negative number, so we only care about the positive square root of this. So square root of 100,000. So this is approximately 316.228. Okay. Right. So how many chairs should be produced in order to minimize the average cost? Well, we can't really produce 0.228 chairs. So here, we'll just round this. So to minimize average cost, 316 chairs should be produced. Right, you could say 316 or 317. Since this rounds to 316, 316 is probably the better choice here, but either way should be fine. Right, so again, let me just summarize real quick. To minimize average cost, we want to set the average cost equal to the marginal cost and solve for Q. So set this, solve Q. Right? That production level, when these two are equal, is going to give you the minimized average cost.